Okay, good morning 11th class. Then today we will study about electronegativity. This one is another important property of periodic table. Now electronegativity, simple, it's a tendency of an atom to attract shared pair of electron towards itself. Now suppose in case of HCl, okay, either in case of normal hydrogen and something जो भी चीज़ है, okay, in that case either it's a HCl, either it's a HF, either it's a H2, so many examples we have. Okay, so in this one they are formed by sharing of electron. So in case of this one, if they have tendency to attract shared pair of electron towards itself, sharing हो रही है, उसने इलेक्ट्रॉन को क्या किया, अपनी तरफ अट्रैक्ट कर लिया, तो दैट वन इज नोन एज इलेक्ट्रोनेगेटिविटी. नाउ कैसे पता चलेगा कि किसकी इलेक्ट्रोनेगेटिविटी हाई है? फॉर दैट वी हैव अ पॉलिंग स्केल. ऑल्दो हमें याद कुछ नहीं करना है, ओके, पॉलिंग स्केल से, ओके, बिकॉज पॉलिंग, अकॉर्डिंग टू पॉलिंग स्केल दैट ही ऑलरेडी कंक्लूडेड एंड ही गेव दैट नंबर 4 to most electronegative element. So your concern is with, you have to learn electronegative element, which one is most electronegative. Okay, so most electronegative element is, that one is fluorine. After that we have oxygen, after that we have nitrogen, after that we have chlorine. Okay, after that जिनकी होगी electronegativity थोड़ा बहुत कम ज़्यादा जो हो सकती है, but most electronegative one is fluorine, then oxygen, then nitrogen, and then chlorine. This one is important, and Pauling gave that value 4 to which one? That one is to fluorine, because this one is most electronegative element. Now on this basis you can easily identify which element attract the electron most. Okay, now just see in this one variation, just see down the group electronegativity decreases and across the period it increases. Same reason, down the group size increases. Obviously if size increases, the tendency to attract shared pair of electron decreases, and across the period it increases. Reason opposite, size decrease हो रहा है तो टेंडेंसी, न्यूक्लियर फोर्स कैसा हो रहा है, बढ़ रहा है, तो टेंडेंसी टू अट्रैक्ट शेयर्ड पेयर ऑफ इलेक्ट्रॉन ऑल्सो इंक्रीजेस. ओके, तो सिंपल वन, दैट्स व्हाई इन केस ऑफ हैलोजन देन फ्लोरीन हैज हाईएस्ट इलेक्ट्रॉन गेन एंथैल्पी. Done. Now next thing we have, that one is anomalous properties of second period element. Okay, 11th class. Then next thing is we have anomalous properties of second period element. Actually anomalous means different. This one means different. Okay, so actually that second period element, they shows different properties from others. And second period element, or either you can say that the first member of each group. For example, in first group, that first member is lithium, then after that beryllium, after that boron, after that it's a carbon, then it's a nitrogen, oxygen, fluorine. Okay, that one, the first member of each group or second period element, you can say that one will shows anomalous, different behavior from other. And that is because of, first reason is small size. This one is because of small size of the atom. ये size में कैसे होते हैं, काफ़ी छोटे होते हैं, and just because of a small size obviously their nuclear charge is comparatively more. Okay, तो उनकी जो tendency होती है attract करने की, that one is also high. The second thing is high electronegativity also. That one is high electronegativity. Then next thing we have, that one is non-availability of vacant d orbitals. Okay, now in this one, simple thing, that non-availability of vacant d orbital, इसमें d orbital होता ही नहीं है, because if you will fill, only we are able to fill up to which shell? That one is second shell, and in case of second shell, how many subshells we have? It's a s and p only. So non-availability of vacant d orbital. Okay, all these are reason for the anomalous properties of second period element. Different. Now another thing we have, that one is regarding to diagonal relationship. Okay, 11th class. Then next one is, it's a diagonal relationship. Diagonal means like this one, diagonal relationship. Okay, so in case of diagonal relationship, why I'm saying कि होता क्या है diagonal relationship? Now in this one, actually just because of similar atomic radius, रिमेंबर वन थिंग, ये पॉइंट इंपॉर्टेंट है, जस्ट बिकॉज ऑफ सिमिलर एटॉमिक रेडियस, इनका साइज लगभग सिमिलर होता है, ओके, तो दे शो सिमिलर प्रॉपर्टीज, कौन कौन, ओके, तो देन द मेंबर ऑफ ग्रुप 1 एलिमेंट दे शो सिमिलैरिटी विद ग्रुप 2 एलिमेंट, मतलब नेक्स्ट वाले के साथ शो करते हैं एंड ऑफ नेक्स्ट पीरियड, मीन्स जैसे ग्रुप 1 मेंबर, ओके, दे शोज रिलेशनशिप विद magnesium, means it's a क्या कहते हैं next group element and even next period element also, okay, just see, and this one beryllium shows similarity with, that one is aluminium, boron shows similarity with silicon, and that is just because of atomic radius, means their size is just because of similar atomic radius, and remember one thing, like this only, ऐसे में नहीं होती, okay, so like this their atomic radius is, okay, similar, that's why their properties are also similar, not same, similar, okay, and this relationship is known as diagonal relationship, okay. Now after that, next thing we have, that one is acidic or basic characters of oxides, metal you can say, okay, or non-metals. So I think you know that metallic oxides and hydroxides, they are, okay, basic in nature, and non-metallic oxides, they are acidic in nature, okay. So how they vary, some are amphoteric also, generally it depends, जिनकी intermediate properties होती हैं, they are amphoteric oxides, but in general case metallic and metallic oxides and hydroxides, they are basic in nature, and non-metallic are acidic in nature. Now how they vary down the group and across the period, just see, okay, now just see, in case of sodium, this one is your third period, sodium oxide, magnesium oxide, aluminium oxide, like this, okay. So in this case, when oxides are there, so across the period, just see, acidic characters increases, reason is because we are going from metal to non-metal, क्या बढ़ रहे हैं, metal से non-metallic characters बढ़ रहे हैं, that's why acidic characters increases. So this one is strongly basic, then basic, these are amphoteric, weakly acidic, like this, and they are, okay, after that acidic, strongly acidic, and then this one is very strong acid. So like this one, acidic character increases, so obviously basic characters decreases across the period. Now down the group, just see, it's a lithium oxide, sodium oxide, potassium oxide, like this one, okay, but this one you can understand with 13th group better, it's group 3 is written, it's a 13th group, okay. Now just see, that one is boron oxide, then aluminium oxide, gallium oxide. So just see, starting acidic, then amphoteric, and basic, it shows what, down the group basic characters increases and acidic characters decreases, okay, you know, because down the group metallic characters बढ़ रहे हैं, तो obviously metallic oxides are basic in nature, okay. Okay, in class, now this one is your last topic of this chapter, that one is defects of long form of periodic table, because now regarding to that all the characters, properties in their ट्रेंड्स या जो भी फिजिकल ट्रेंड्स वगैरह थे इन प्रॉपर्टीज, ओके, दैट वी हैव ऑलरेडी डन, वो सारा हो गया. नाउ दिस वन इज लास्ट टॉपिक, तो व्हाट आर द डिफेक्ट्स ऑफ लॉन्ग फॉर्म ऑफ पीरियोडिक टेबल. नाउ फर्स्ट वन इज, दैट वन इज द पोजिशन ऑफ हाइड्रोजन इज येट नॉट डिफाइंड. पोजिशन जो है वो हाइड्रोजन की अभी तक भी डिसाइडेड नहीं है. रीजन इज बिकॉज हाइड्रोजन शोज सम सिमिलैरिटी इन प्रॉपर्टीज विद फर्स्ट ग्रुप एज वेल एज विद 17th ग्रुप, वो दोनों के साथ प्रॉपर्टीज शो करता है, एंड दैट विल स्टडी इन चैप्टर हाइड्रोजन इन 11th क्लास ओनली. वी हैव हाइड्रोजन चैप्टर, तो विल स्टडी इन डिटेल. नाउ सेकेंड थिंग इज, यू नो, लैंथेनॉइड्स एंड एक्टिनॉइड सीरीज पीरियोडिक टेबल के सबसे नीचे, ओके. तो वाई सेपरेट प्लेस गिवन टू लैंथेनॉइड्स एंड एक्टिनॉइड, उसको उन्होंने मेन उसमें क्यों नहीं रखा पीरियोडिक टेबल में. तो बोथ आर द ड्रॉबैक्स ऑफ पीरियोडिक टेबल, और यू कैन से इट्स अ डिफेक्ट ऑफ लॉन्ग फॉर्म ऑफ पीरियोडिक टेबल, ओके. थैंक यू.